Right now, your phone knows where you are, down to a few steps. A little blue dot on a map, and it just works. But that dot is pulling off something impossible without a long-dead physicist. To find you, your phone quietly listens to clocks floating in space. Not one clock, several of them, all at once. Each satellite shouts one thing over and over, the exact time and exactly where it is. Your phone hears that message a hair late because the signal needed time to travel down. Multiply that tiny delay by the speed of light, and you get your distance to that satellite. Do it with 4 satellites, and the 4 distances cross at exactly one spot, you. So the whole trick is timing. Position is really just a careful measurement of time. And here is where it turns frightening. Light travels about 30 centimeters in a single nanosecond. A billionth of a second of clock error is about a foot of position error. Be off by a millionth of a second, and your dot leaps the length of 3 football fields. So these clocks must be almost perfect. They are atomic clocks, good to billionths of a second. And that is exactly the trouble. Once a clock is that good, Einstein comes knocking. Einstein said time is not a fixed backdrop, it bends. 2 things bend it up there, and they fight each other. First, motion. A GPS satellite tears around Earth at about 14,000 kilometers an hour. Special relativity says a moving clock ticks slow, seen from the ground. That motion alone makes each satellite clock lose about 7 microseconds a day. If that were the whole story, the fix would be simple. It is not. Because the second effect shoves the other way, and it is the bigger one. That satellite sits about 20,000 kilometers up where Earth's gravity is weaker. General relativity says a clock in weaker gravity ticks fast. Up there, that lighter gravity speeds the clock up by about 45 microseconds a day. So take the 7 the motion steals, subtract it from the 45 gravity adds, and you land on the famous number. 38 microseconds a day. Physicist Neil Ashby, who wrote the reference paper on this, pins the net gain right there. 38 microseconds sounds like nothing. Watch what it does to you. Left uncorrected, your location would drift by about 10 kilometers every single day. Your navigation would be useless before lunch on the very first day. So the engineers built Einstein straight into the machine. That is the clean, honest answer. But that tidy answer hides something a lot stranger. You would expect the fix to be a line of code. It is not, at least not the main one. The main correction is burned into the hardware before the satellite ever leaves the ground. A GPS clock is meant to tick at 10.23 megahertz once it is in orbit. So on the ground, they deliberately set it wrong, tuning it slower to 10.2, 29999999543. They build the clock broken on purpose. Then relativity, once the clock is up there, speeds it up to exactly right. Think about that. On the ground, that clock is wrong. In space, the same clock is perfect. The universe itself finishes tuning the clock for them. And here's the part almost nobody hears. At first, they did not fully trust the theory. In 1977, the United States launched a test satellite carrying an experiment. It held the first atomic cesium clock ever placed into orbit. Some engineers were not sure Einstein had the exact size of the effect right. So they hedged. They built a switch. One setting ignored relativity. The other turned the correction on. They flew it, ran the bare clock for about 20 days, and measured the drift. Ashby reports the clock was running fast by about 442 parts in a trillion. That is 38,000 nanoseconds a day, landing right where Einstein pointed. Prediction and reality disagreed by only about 4 parts in a trillion. They flipped the switch to Einstein. It has stayed on ever since. Relativity was not simply assumed. It was tested in orbit, and it passed. Now, one honest caveat about that neat 10 kilometers a day. That number is a clean average, not the whole living machine. The big steady part is the factory offset we just saw, locked in before launch. And ground stations keep rechecking and nudging the clocks, so relativity is one correction among several. But strip relativity out, and the errors truly do pile up fast. On that, the physics is settled. There is one more room, and it is sitting in your pocket. The satellites do not fly perfect circles. Their orbits are slightly egg-shaped. As a satellite dips nearer and then swings farther, its speed and its gravity keep shifting. So relativity does not just add a steady offset. It adds a small wobble that changes minute to minute. That wobble can reach tens of nanoseconds, enough to throw your position off by several meters. A fixed factory tweak cannot chase a moving target like that. So who catches it? Your receiver, the little chip inside your phone. Every satellite beams down its own orbit shape. Your phone runs the relativity math itself, live, over and over. You are carrying a tiny relativity engine, and you never feel it run. Ashby notes that cheap trackers skip this and simply live with being about 100 meters off. But the blue dot that drops you on the right doorstep does the math. So go back to that little blue dot. It looks like the simplest thing on your whole screen. But it only lands on the right street because a clock in space runs fast. A clock on the ground was built wrong on purpose, and a machine in your pocket quietly bends time back into place. You are not lost. You are standing on top of Einstein, and you never even noticed.